Okay, hello. Good evening, everybody. So it's already 6:06. In the interest of the time, we'll start as soon as possible today. So, how was yesterday's session, and anything from your side to be said regarding yesterday's session? Any inputs you would like to give? Or anything you want to share that you have discovered yesterday after the session? Guys, speak up today. Today's session is a practical one. We need you to be interactive and learn as much as possible from this session. Okay, first of all, how many of you don't have any touch or any experience with any programming language? Can you raise your hands? Okay, Sharat, one. Anybody else who doesn't have any experience, like zero experience? Oh, okay, that's it. Then Sharat alone. Okay, then. So what we are going to do today is our agenda is, anyways, it is evident from the session name, that is programming and simulation. So we are going to program the microcontroller called Arduino Uno R3. So as you went through the session day 2, microprocessors and microcontrollers, the Arduino Uno R3 is a type of microcontroller. So we are going to interface the microcontroller with whatever sensors you have studied yesterday. Not all, but you are going to see some. So this is what today's agenda is, and this is how it is going to be practical. And since we are in different locations, we are doing it on an online software, an open source software. I hope every one of you have created an account on the Tinkercad platform. If you haven't, please do so now, right now. How many of you haven't created? Yeah, Dwarganathan, please, could you create now as soon as possible?
Can you repeat once again its name now?
Yeah, that's Tinkercad. Our RCS has sent the prerequisite, right, in the mail. You will find out the link there, or else I'll give the link to Tinkercad. Just a second.
Yeah, I've put in the chat box. Yes, you can check it.
Yeah, I'm sending. Okay, I've sent. So, okay, meanwhile, shall we revise what a microcontroller is? Can anyone tell what microcontroller does, or what is the job of microcontroller? Guys, you can either type in or you can speak up. We want it to be interactive. Yeah, nobody knows what is microcontroller. Am I audible?
Yeah, Dheeraj, do check the chat box.
Chat box. Right. Its job is similar to human brain, but human brain does multiple processes. What is the difference between the controller and processor then? Correct. It performs the same specified task repeatedly. Correct, Priyadarshini. Yeah, Vantika, it is an integrated circuit of which does specific operation, right? All right, amazing. Sherlyn, you are giving answer for microprocessor or controller? Correct. Okay. Right. So please be the same interactive in the upcoming practical session. And okay, so before we dive into the programming part, I would like to tell you that I'll be handling regarding the Arduino microcontroller. We need to know technical specifications of this microcontroller, and I'll be also handling the programming part. And the second phase of this session is regarding simulation with the sensors that you have learned yesterday. So that will be handled by my friend Manindra. So let's not delay it. We'll start with the session. Just a second, I'll change my presentation. I hope my screen is visible and the pin diagram is visible. I need a response, please.
Yeah, it's visible, Dheeraj.
All right. So what you are seeing on the screen is the Arduino Uno R3 microcontroller. It's pin diagram on which various number of pins are marked here. So, okay, I'll share you the resource, but not all pins are important as of now for our session. You may explore it later also, but I'll tell you the in a very short manner and crisp manner. So, okay, let's start with it. The pin number 1, which you are seeing, is a power USB. Okay, that is used to power the Arduino board. This board can be called Arduino also. You need not always call Uno R3. Uno R3 is just because it is a.
Can we get the maneuver though?
Organizer, can you please?
Hold it wheel to wheel.
Yeah. Okay, so the pin number 1 is USB port through which you can power your Arduino board. You need not call Arduino Uno R3 because Uno R3 is always uh, pronounced just to uniquely identify the board, because there are various models and various differences in models of this Arduino microcontrollers. So that is what Uno R3 is for. So this first pin is nothing but your USB connection to power your Arduino board, because for any board to work, the power is the basic source, right? So this is how the pin number 1 is useful to power your Arduino board. There are several ways to power your Arduino board. We'll see some more. The second one, the second pin number you are seeing, that is a barrel jack. So in this, a jack kind of thing will be there, which you can insert into it directly from the main supply. Your AC mains power supply is there, right? You can use that same supply to power your board. And there might be a question arising in your mind that in our homes it is 240 volts running, right? So how come that such small microcontroller can bear that? So for that purpose, we have a voltage regulator. For those who don't know what voltage regulator is, in layman's term, if you have 100 volts of supply and your appliance or something, you can take your air conditioner. Okay, for your air conditioner to work smoothly, it needs a stable voltage supply. So you might have seen stabilizers installed in your homes. So that does the same work of the voltage regulator. What it does is, suppose in your homes for domestic usage, it's not always 240 volts. It is fluctuating. It is sometimes 248 or 250, and sometimes it is 230. Some fluctuations happen. So for stabilization purpose, stabilizer is there, and the same thing is this voltage regulator. The number three, which is representing, is the voltage regulator. So that is what it does here in this case. And the number 4 you are seeing, it has a very important role. This is called crystal oscillator. Okay, crystal oscillator, in the sense, you might have studied in your 12th standard LC oscillator. So this is not that thing. This oscillator has a purpose, that is, it keeps track of time. So it calculates time with respect to the number of oscillations in this small thing, crystal oscillator. So the frequency of this is 16 into 10 to the power 6 hertz, or 16 megahertz. Please keep a note of it. It is 16 megahertz. And it's a simple math. How do you calculate time from the given frequency? Yeah, anyone can answer.
1 by frequency.
I think, yeah.
Inverse.
Correct. Right. So, okay, let's move on to the next pin. That is pin number 5. Pin number 5 is like a reset button. Okay, if you want to, it's similar to your laptop. You have a reset pin on right or left hand side, correct? And but there you use some safety pin or something to push into it, right? But here you can connect an external switch, which you can turn. When you turn it on, press it, it may reset the entire Arduino setup, right? And then pin number 6, 7 are supplies, 3.3 volts and 5 volts, which you can make use of, right? You can power anything. It is just like a supply you are giving to make use of it. More generally, we don't, but if you need any supply, you can make use of this from this board itself, right? And pin number 8 is ground, and the ground is, I hope you know what is ground. You have studied in your schooling level. That is, for any electrical circuit, you should have a negative terminal as ground, so that your entire circuit forms with proper voltage difference. Grounding is important and must. And this 9th pin, that is where you can power your board. This is also another way. So in total, how many ways you can power your board till now we have seen? Yeah, anyone can answer? How many such, several ways are there? So can anybody name at least the pin numbers? In the pin diagram. Yeah, 3 ways. Can you name the numbers on the diagram? Nobody knows? Not 10, 10 we didn't discuss yet. Yeah, 1 to 9 is the right answer. Correct. 1 to 9 is the right answer. Avantika, 6 and 7 are powering the external devices. Like you can take electrical supply from Arduino. I am asking how can you power your Arduino board? Like giving supply to the Arduino board. So there are three ways through 1, 2, and 9 on this diagram. Yeah, correct. 1 to 9 are the right answers. So, okay, moving on to the 10th representation of pins, that is analog pins. Guys, do you have any idea regarding analog signals? Do you know what is digital signal? What is analog signal? What is the difference between these two? If you don't know, please raise your hands. I'll just clear it in layman's language. Yeah, 0 and 1 for what? Can you tell Avantika? Right, digital. And for analog?
It is in wave form, I guess.
Waveform for analog.
Yeah.
Yeah, more apt, that is continuous. The words continuous and discrete are important. Digital signals are discrete. Discrete in the sense either they are 0 or 1. So, this graph of, if you draw a graph for like time axis versus 0 and 1 on y-axis. So let us say for every 2 seconds, your cycle changes 0 and 1. So you will see, rectangular shapes, if I'm not wrong, if you are able to visualize. Yeah, Himanshu, sine and cosine. Yeah, correct. They are continuous functions and they are analog, example of analog signals. Correct. So when you visualize your graph for this, so discrete signals, those zeros and ones, either it is a 0 or 1 in a given time frame. That is called a digital signal. And yeah, as Himanshu said, the continuous functions like such as sine and cosine are continuous signals, which are analog signals. Right? I hope that is clear regarding digital and analog signals. So to send your analog signals such as this sine x function, sine and cosine functions, you should send such signals to these A0, A0, A1, A2, A3, A4, A5, right? Either to take output from this or else input from, or else you want to give some input to this board. Okay, you will be seeing the use of this soon. And coming to the 11th representation, that is the main IC. Somebody mentioned integrated circuit. Yeah, here it is. The 11th representation is the integrated circuit. That is the main head of this whole microcontroller. So the company, I think some Atmel company, that is something which manufactures this IC. So if you have done your digital system design labs, you might have seen the IC. You might have worked with 7408, that some AND gates, XOR gates, etc. So similarly, this is the IC for working of this microcontroller. And whatever you will be programming will be given as a set of instructions for this IC, and accordingly you'll get outputs. And then 12th is called ICSP pin. So that is not of much use for us, but okay, I'll tell you in layman's language, that is nothing but it acts as a just like an output header, like whatever you see as an output from this microcontroller. If you have heard the serial bus in layman's language, it is nothing but all the peripherals connected on this board, like peripherals, maybe the digital pins, the power, and all such things connected at one place is called a bus. All the hardware components. So this thing, you can say it'll control all these peripherals. So that is what the use of this ICSP pin. And the 13th representation is that power LED indicator. Whenever you power your Arduino board, that will turn on. As simple as that. And the 14th one are like, they are of, again, no use to us. They are called TX and RX LEDs. Like when you transmit data, the TX will turn on. And when you receive data, the RX will turn on. So, I mean, either they will flash according to the baud rates. Baud rates are nothing but like the rate of transfer of bits, you can say. Right? If I say a baud rate of 10,000 I have given, then it means that you are transferring 10,000 bits of data per unit of time. The unit of time may be second or whatever. It depends on the manufacturer. And then comes your 15. 15 representation is all the pins from 0 to 13 are digital pins. All right. You are seeing some negation, I mean tilde sign, right? That tilde sign represents that pin is a PWM pin. What is PWM pin in the layman's languages? It is nothing but just like, let us take 2 seconds of time frame. And let us say that your your digital signal was like high, in the sense we'll talk in high or low terms. Okay, high means 1 and low means 0. So it was high for entire 2 seconds time frame. So it was giving some X amount of output. Okay, now I will say I reduced my high time to just 1 second of this 2 seconds time frame. I mean, I halved it. So only for half of the time it is high and half of the time it is low. So what output should I expect? Can anyone tell me? What output I can expect if my microcontroller gives, if my signal was 100% for entire time frame, it gave X output. Now it is high for only 50% of the time frame. What should be the output? Hello? Sorry, frequency. Frequency is doubled. No, not about frequency only. I'm asking with respect to the output. Output is nothing but here, the work done. Or the correct. Venkataraman has got it. That is, yeah, reduced to half. Yeah, Sherlin is also right. That is reduced to half. Correct. So what we term this is as duty cycle. The amount of time your what do you call, the digital signal is high. That is the amount of time for which, that is the period of time which is termed as duty cycle. Okay, whatever the percentage it may be, some XYZ percentage, the same percentage of work will be done on the other end. I hope that is clear. So those are those pin. Those are termed as PWM pins here on this microcontroller. Either you can take input or you can give output. All right. So pin number 16 is of no use again for us, and the pin number 17 is also no use for us. All right. So this is what the pin diagram representation is. Yeah. Someone wants to repeat. Yeah. PWM pins. First of all, Did you understand PWM signals? Like, did you understand this duty cycle and all? Okay, so in PWM pins, what you can do is you can manipulate for for example, you are giving digital input to some kind of peripheral device you are adding to it. Okay, for example, you'll soon see in the ultrasonic sensor, we'll be giving inputs to it. Okay, so we are going to manipulate duty cycles there according to the time. And how are we keeping the track of time? That is through this crystal oscillator, the pin number 4. I mean, the representation number 4. Okay, so accordingly, we'll be manipulating for how much time the signal goes high and for how much time the signal goes low. Is that clear? It is your wish for how much time you want to keep it high and for how much time you want to keep it low. It depends on you how much the duty cycle is. It may be 75%, it may be 50%, it may be any odd number, 59%. It may be anything. It depends on how much time you have given for it. Okay, you will see how this we are keeping track of. You'll see soon. Okay, so I hope that is clear about the microcontroller. If you have any doubts, please ask. We are soon moving to the programming part. If everything is clear, let's move on to the Tinkercad session. We'll see first some basic programming, how to do. Don't worry, it'll be a simple one for those who have basic experience at least. Someone, I think Sharat doesn't have any experience. Sharat, it will be easy. Yeah, Srigant, you are raising your hand. Are you having any doubt?
No, sir, no.
Yeah, don't call me sir. I'm just your brother.
Okay, okay.
All right. Anybody else has any doubt, or you all are clear? Okay, then we'll proceed to the basic programming part. Just a second, I'll stop presenting and okay. And meanwhile, Manindra, are you here?
Yeah.
Yeah, can you just show how this real Arduino Uno R3 looks
Yeah,
like?
sure.
Yeah. Guys, just observe how does
Yeah.
it look in real hand.
This is how exactly the Arduino will looks like. Same like in Tinkercad.
Can you see how small it is?
It is fit into my half of the arm. Yeah.
Okay, thank you, Manindra.
Yeah.
Yeah, I'll be sharing the tab. Okay, I hope you guys have created the Tinkercad. Your homepage will look like something like this. Basically lands up into the 3D designs. Are you all on the same page? As I am on this window, I am not able to see your this meeting tab. So just unmute and say yes or no. This is Tinkercad, and the link is already in the chat box. you can create your account and just log in. And don't worry, even if you don't have an account, you can create later. We'll soon share the links of the simulation. You can copy it. Okay, rest others. It's in the chat box. Please check it. Yeah, are we good to go? All are on the same page? Himanshu, the link is organizer. Can you post the link again? Yeah. Okay.
Yeah,
Thank you,
post.
Manindra. Okay, guys, I want to see because I'll go with the majority of people. Can you guys tell if you are on the same page? If majority of people say yes, we'll move forward.
Yes, now.
All right. Others. Yeah. Okay, just 5 people. 6, 7, right? Except these 7, nobody has created an account here. 8, 9, right? 10, 11, right? 12, 13, 14, correct? 16, yeah. Okay. So, okay, as you are responding, please respond in the same manner for each and every question in the session. So, all right, I can see majority of the responses to be yes. We'll move forward. Okay, this is your dashboard and this is the landing page when you log in. Go to circuits and you can create, click on create new circuit. All right, I'm going to show you. Okay, let's do a new circuit. All right, to familiarize with this UI, let me just tell you 2 minutes of introduction. You can name your simulation here. You can give any name. Just click on it. You can name it whatever you would like to. All right. So here you can name it. And so you will find out your components here. A resistor, LED, and you will find out sensors also, which my friend Manindra will be taking you through. Now, firstly, we'll bring out our Arduino Uno R3. Okay. Okay. Why do you think this part is here? I mean, only this is a microcontroller, right? Hello? Any guesses? I mean, I don't expect any answer, but if you have any guesses or any kind of input regarding this, just think with respect to the pins I told you. I mean, those pin diagram representation. What is this actually? Correct, correct. Yeah. Who is it? Can you tell your name? Sorry?
I'm Sherlyn.
Yeah, Sherlyn. Yeah, you're right. So here we are powering the USB, this microcontroller. Without powering it, you cannot, run anything on this microcontroller. So you need to power through this or through this jack, or else through the VIN. All right. So okay, we'll see programming now. Click on code. And okay, here if you want to give any name, you can give it my Arduino. Okay, and click on code. Here you can practice with blocks. Okay, but I would teach you with text. Okay, change it to the text. All right, you can remove this code. We'll go stepwise. Okay, how many? I mean, you might be familiar with your C programming language at least, because we have first years, second years. Okay, second years might be knowing C++ also. If you have touch with C programming language, that's good to go. Okay, for those who don't know any programming, you'll certainly learn a part of what you will learn soon. So okay, basically talking about the structure of programming, also known as technically structural construct of this programming language, it will mainly contain two functions. Okay, you can see on my screen the setup and the loop. Okay, what setup function does is this function. This function is called only for once, like in the very starting of the simulation. Okay, just like to initialize, like you do int x is equal to 4. Like this is the declaration. Before you use your variable x, you need to declare with what data type it is. Here you type in data type. As it is an integer type, you are specifying it as an int. If it was a character, you'll specify with char and variable name. And if you want initializations, you may not need do here. Okay, and this whatever you declare here will be termed as global scope variables. Like you can use this variable in this function as well as this function. If the same you do in the setup itself, you may not be able to use this in loop. I hope that is clear. So for purpose of global use, we'll put it here. And if you want some value to be in the X before you start your main executions, in the setup function, you can initialize with whatever value you want. I'm initializing with X is equal to 4, right? And I'm initializing Y equal to some capital A because it is a character data type. Right, and it also follows the ASCII characters. If you know, the ASCII is like the ASCII value for this this character. If you give it here, the internal casting will be done. Implicit casting will be done to the character. So can anyone tell me ASCII value for capital A? Yeah, 97 is for small a. 65 was the right answer. Yeah, correct, Sherlyn. So 65 is the right answer. If you give 65 also, it will work. So that is why I was saying it is similar to your C programming language. And someone didn't have any experience. I think Sharad, just look how we are going to initialize and how we are making use of this setup area and this loop area. That will be enough for you. and others can go through it deeply. Avantika, what I said was we'll have two functions, namely setup and loop, for this programming construct in this Arduino programming. Okay, this is termed as Arduino programming. So setup function, this is a function, right? So this will be called only for the first time, like when you start your simulation. After that, it won't be called. Okay, so if this function is called only for once, then it is enough that you initialize whatever variables you declared here, correct? So that is what setup function does. And later on in loop, you can do whatever manipulations you want to do. For example, I wanted to add 10. Okay, and this loop function, what it does is it gets executed again and again after once the setup is executed. So there is something called as serial monitor connected to this Arduino board. We saw the ICSP pin, right? That is the output header which will give us output. So before that, there is a class called serial. I mean, don't take it as technical terminology. Just take it as you are attaching baud rate. I spoke about baud rate, right? The transfer rate of bits per second or per unit time. So here we give it as 9600 generally for Arduino microcontroller. Okay, if you won't give this line, then your serial monitor won't be showing any outputs. Okay, I'll show you. For printing purpose, you will use serial.println. Okay, and you will also print y. Okay, so println is like after printing this, add a new line character also in the end. So whatever you will print next will be printed in the new line. So that is what println is for. If you remove ln, it will print in the same line. Is that clear? We'll once simulate and see.
Now, what is the use of serial now?
What is the use of?
Why we are mentioning serial?
Here. Yeah, this is for connecting your. Okay, there is something called a serial monitor. Okay, here you are able to see, right? This is where whatever you are printing, that will be printed here. Now, if I'll comment this, it won't print at all. See, simulation has started. See, simulator is going on, but nothing is being printed. 14704A was previous output. Okay, you're saying there is no output. So there is something called a serial monitor. To initialize it, we are using serial.begin. Okay. Yeah, for technical terminology, as my friend has mentioned, it is a class and it has a function called begin, to which you give the baud rate, the number of bits that are transferring per second. Okay, so if I uncomment this and I'll run now, you'll see, yeah, you're able to see, right? So this is what serial class does. All right. So, and also, did you understand how setup and loop are working? Did you understand how setup and loop are working?
Yes, bro.
If I don't initialize these, you'll see some other value, some junk maybe. Okay, it started from 0. And it has taken character y as 0. or yeah, that's it. So that is what this setup function is for. And okay, let us do one thing. We'll take input also. You can give input also, right? Let us say we'll take string z. Okay, you need not initialize here. What you need to do for taking input is you need to wait for the serial monitor until it is available. Okay. So Z will be, I'll tell you what this is. And here instead of X, we'll print Z. So it will wait for you to give input. Until then, this is what serial dot available equals to 0. So once you give input, this will return value 1 because of this, which it will exit and it will read the string and give it to Z. So for example, I give my name. See, it has printed my name here because we gave serial dot print Z and print ln y. So that is why Z and Y, I mean character A, these both are printed in the same line. If I give another some input A, B, C, D and click on send, see, it has gone to new line and that is how it goes on. I hope that is clear. This is what the basic thing is, and there is something called as pin mode. We'll see pin mode soon. Before that, we'll see a delay function. Here, you can pass on how many milliseconds you want to delay this code. Okay. For example, I want to put a delay between printing of the string Z and the character Y for at least 2 seconds, which means 2000 milliseconds. All right. So I'll give you JKLMN. I have given the input. It has printed Z, waiting for 2 seconds, and printed A. Is that clear? I hope that is clear how delay function works. Now also simulation didn't stop because this loop is again working again and again, but it stopped because of this. It is waiting for input from your side. So to stop your simulation, click on stop simulation. That will stop everything. You can clear your console here. So that will clear your serial monitor as well. I hope that is clear. I need a response from your side. If you have any doubts, please ping us. Yeah, we'll see a small example so that you get to know how to simulate. Basic, I'll show you blinkers. Okay, so shall we move on to the blinker? Yeah, all right. Okay, we'll share this link also with you. You can go through this. And now we'll see internal blinker, right? I think when you open a new circuit, I am having already this circuit. If you open your new circuit, I think you are already having built-in this, LED program. Void loop, yeah, bro. You cannot run your program without this loop function. Is that clear? So I think this will already appear in your, whenever you open your new circuit. Yeah, open new circuits, please. So if you have opened your new circuits, you will see the same thing. Change here to text and you'll see this code. So I hope everybody has opened this. Hello. Am I audible? Oh, yeah. Okay. Correct. Okay. Okay, then. So, yeah, we'll go through this code. I'll explain you. So I was telling you about this pin mode function, right? This function accepts two arguments. First one is the pin number. All right. And the second one is the mode. Technical team, can you just assist them? Someone couldn't get it open. Just yeah, I was saying just click on the create new circuit. Go to your dashboard. Like this is your dashboard, right? Go to circuits, create new circuit. See, I'll create for you. Okay, and go here and bring in your Arduino Uno R3. Okay, go to code and just go to text. All right. Now clear? Okay. Okay, in that code I had 13. Okay, this is a constant. Okay, I mean a constant value similar to the const you declare in your C code, C programming. So LED built-in is equivalent to the number 13. Is that clear? So whenever you write LED underscore built-in, automatically the number 13 is passed here. So an alternative for this. (13, output). So as of now, I'll comment this. This is equivalent to this. All right. So now what you are doing is you are setting up this 13th pin to the output node, and this is what setup function is doing. You are calling it once, and for once you are setting it as output. That's it. Your work is done for initialization. Right now in the loop function, what you will do is you want to make it as a blinker, right? So you should go high and go low. So that is what I was talking about. We'll talk in terms of high and low for digital signals. So whenever you are writing a digital signal, you will make use of digital write function, which accepts again two arguments. First argument is the pin number. The second argument is the signal that you want to do. Here in this case, I want to turn on the built-in LED that is at pin number 13 again. Okay, LED built-in is equivalent to the number 13. I want to go high for 1 second, so 1000 milliseconds. That is why I'm putting a delay of 1000. Similarly, I'll go low for 1 second. That is here, a delay of 1000. If you see your simulation, you all can simulate, and you can see the built-in LED going on for 1 second, going off for 1 second. We can manipulate this. You can make high for 2 seconds, and so you'll give 2000 here. Now we'll see this. See, it remains on for 2 seconds and off for 1 second. Is it visible? So it is on for 2 seconds and off for 1 second. So this is how internal blinker works. And instead of LED built-in, you can give 13 number here. Okay. I hope that is clear. Now we'll go for an external blinker. If everyone is okay with that, we'll go for external blinker. Hello?
Yes, no.
Hello? Yeah, can we go on to the external blinker?
You can
We'll
carry
put
ahead now.
we'll put a what do you call this external LED, and we'll simulate. Okay, if that is okay, then yeah. Yeah. Okay. So now to build your external blinker, you need LED, a breadboard. Okay, first we'll import a breadboard. A small, import the small one. Then you need LED also. This LED. You can see, right? You need to import that LED and place it horizontally in one of the rows that you are able to see. Like you can place it over here. Okay. And then you need to take a resistor. Why you will put resistor is because the LED may blow off. So you need to put a resistor so that flow of electrons is smooth. Okay, so take a resistor and you will connect it to the cathode part. Okay, and we'll give connections to the positive. I mean, as you have connected the cathode of this LED to the resistor, now you need to give I mean, you need to ground one side, okay, and you need to give signals to this LED from one side. So you will give signals from where, like you need to choose a pin. Okay, let us choose pin number 8, and we will give input from here directly to this. Okay, and you need to ground this part, right? Otherwise it won't work. So take one ground and you can just connect it here. Okay, I hope everyone did that connection. You need to manipulate your code. So now here in this case, we connected pin number 8 to this, right? We are giving signals to this. So what should be the argument here instead of LED underscore built in? Can anybody tell me? Yeah, correct. That is pin number 8. You're going to set up that pin number, that pin mode as output, correct? Now you can run this program once you change all the values here, 8 and 8. Okay, because you are digital writing through this pen, right? So you need to give the correct argument here. All right, make the changes, and then just you can start simulation. We'll see if there is any error. Okay, you can see, right? Your LED blinks for 2 seconds and goes off for 1 second. I hope that is clear. Guys, is this working for you? Yeah, clear, right? Okay, so I'm stopping the simulation. If you have any doubts, just let me know. So my friend Manindra will take over this session now.
What should be observed here?
Yeah. Pardon?
What should be observed here?
Here, you should see how your simulation, I mean, the whatever pin mode you have, I mean, whatever pin you have connected to this, make sure you have given those numbers. And after that, while you are simulating, this is an external blinker, okay? You have connected LED here on this breadboard. Okay, so you need to observe your external, like, is your board writing signals here? And is it taking, see, whenever it is high, it is glowing high. I mean, the LED is glowing on. And LED is having two electrode side, one is cathode and one is anode. So this cathode part or anode part, you can connect either of the two. Yeah, correctly pointed by Gautam.
Understood.
You must, yeah, you understood? Okay, I'm stopping the simulation. If you have any doubts, let me know. Now Manindra will take over this session and we'll continue with some other sensors. Over to you, Manindra.
Yeah, thank you, Vidhiraj. You can stop the presentation. Yeah.
Yeah.
Hi
Stop.
guys. Hi guys, I'm Manindra from Computer Science Department, third year. Let me share my screen. Yeah, is my screen visible?
Yeah.
Yeah, thank you. Yeah. Now let us discuss some sensor stimulations in the Tinkercad. Now I'm creating a new circuit here. Yeah. Yeah. How many of you know about the ultrasonic sensor? Hello? You can type it in the chat. Do you guys know about ultrasonic sensor? Yeah, it measures distance exactly. And what kind of waves does the ultrasonic sensor emits? What kind of waves? Yeah, sound waves, exactly, Vedarshini. Yeah. Yeah, okay. The basic working principle of the module is simple. It sends the ultrasonic pulses which travels through the air, and if there is an obstacle or an object, it will bounce back to the sensor. By calculating the travel time and the speed of the sound, the distance can be calculated. Basically, if you see here, it consists of 4 pins. One is VCC pin and means the power pin and the ground pin, and the other 2 pins are trigger pin and echo pin. The trigger pin is used to trigger the ultrasonic sound pulses, and the echo pin produces a pulse when the reflected signal is received from the obstacle or something. Is everyone clear with that, right? Okay, let us take the Arduino. Okay, let's make the connections. Power supply is connected to the 5 volts of the Arduino board. Ground pin is connected to the ground of the Arduino. And this trigger pin and echo pin you can connect to the digital pins of the Arduino. You can connect to any pins. In my case, I'm connecting the trigger pin to 3 and echo pin to 2. Is everyone clear with the connections, right? Can I get a yes from the chat box? Yeah. Remaining people? Yeah, Karunya, yes. Yeah, okay. Then we'll see the coding part here. in this code, initially we have to define the pin configuration. As we connected a trigger pin to 3 here, we'll define the trigger pin as 3, and we'll define the echo pin as 2. As we connected the trigger pin and echo pin to 3 and 2 pin digital pins of Arduino. After this connection, we'll using two variables as duration and distance. Duration variable for calculate the duration required for the sound wave to generate and reach up to the obstacle or object, and with the help of the duration, the distance will be calculated. As our members already discussed, the speed equal to distance by time formula. Everyone is know, right? With the help of the duration, we'll get the time, and with the speed means the speed of the sound wave, we can calculate the distance. Is everyone understood that? Yeah. In the setup, we'll declare the pin configuration, pin mode, trigger pin is for output and echo pin is for input. As we are emitting the sound waves from the trigger pin, we put it as output, and from the echo pin, we are receiving the sound waves which are reflecting back from the obstacle. So we are taking the input from the echo pin and we are giving output from the trigger pin. And as usually, we are starting the serial monitor with serial.begin with the 9600 standard baud rate. This is the void setup, and in the main void loop, we'll write the main logic. As Dheeraj discussed before earlier, void setup will execute only one time, and the void loop will execute infinite times. Until we stop the stimulation, it goes on executing. In void loop, digital write, trigger pin as low. Initially, we'll keep the trigger pin as low for 2 microseconds. And then we'll keep the trigger pin high for 10 microseconds. Again, we'll keep the trigger pin as low. I'll explain everything. Yeah. Initially, we have to keep the trigger pin as low for 2 microseconds. After that, we'll set the trigger pin high for 10 microseconds, and again we'll keep it as low. This is because we'll trigger the ultrasonic sound for 10 microseconds, and then we'll start reading from the echo pin whether the sound waves are reflected back from the object, like whether the obstacle is present or not. We'll calculate now. We'll calculate the duration with the help of the pulse-in function. Here, pulse-in function reads the echo pin and returns the sound wave travel time. Basically, with the help of the pulse-in function, we can get the sound wave travel time. Is everyone clear with the pulse-in function?
Now, can you repeat once again?
Yeah. Actually, what the pulse-in function do is, it reads the echo pin. It reads from the echo pin, because echo pin is for input, right? So it reads the echo pin and gives the sound wave travel time, like how much time it takes to return back from the obstacle to the sensor. Is that clear? Yeah, Shweta, the trigger pin is kept as output because from the trigger pin we are sending the sound waves, and the echo pin is used for receiving the reflected sound waves from the obstacle. That's why you keep the trigger pin as output and echo pin as the input. Is that clear? Yeah. Pulse-in function is clear to everyone, right? It helps in calculating the sound wave travel time. It basically for calculating the time, how much time it's taking to get reflecting back from the sound wave. Okay. After that, we'll find the distance. Distance equal to speed into time, right? We're having the time as duration. So duration into what is the speed of the sound? Can anyone mention in the chat box? Speed of the sound.
$330 meters per second.
330 meters per second. Very close. $360. Okay. Yeah, basically it is 340 meters per second. 340 meters per second. Okay, 340 meters per second equal to in centimeters how many seconds per second? In centimeters we'll multiply by 100, right? It basically 3400 centimeter per second, right? Yeah. Now we have to take the speed of the sound in centimeter per microseconds. You can ask why particularly microseconds, because as Dheeraj discussed earlier, the clock speed of the Arduino is 16 megahertz. One hertz equal to 10 power 6 megahertz. So to satisfy that, we have to consider this in microseconds, as 1 second equal to 10 power 6 microseconds. So we have to calculate the speed in centimeter per microseconds. So the speed of the sound is in centimeter per microsecond is 0.034. Is this clear to everyone? Can I get a yes from the chat box? Or can I repeat it again? Yeah. So we'll write 0.034 by 2. Can anyone guess why I am doing by 2 here? Why I am dividing by 2 here? Make a guess. We have to divide we are dividing the speed by 2.
Since it's back and forth.
Yeah, exactly. What's your name? Rohit. Yeah, exactly, Rohit. As the sound waves are going and coming back, we are dividing by 2. Yeah, then we'll got the distance. We'll print it in the serial monitor. I'm printing the distance here. Okay, let's start. Let's simulate and see whether there are errors in the code or not. Yeah, there is no error. See, if I am changing the distance, if I am changing the obstacle, the distance is kept on changing. Are you guys able to see? 187, 152, 79. Are you guys able to see? Yeah. Yeah, I'll share the link of this design. You can try to tinker this design. I'll share the link. Try whether it is working perfectly for you or not. Just click on the link and try to tinker that design. Is that link working? If you are getting the correct output, just type yeah working in the chat box. Open the link and click on the tinker this. Just tap on the sensor. You'll get an obstacle. Then you can able to move that obstacle. Yeah. Others guys. Only one person is doing. Yeah. And yeah. Okay, then shall we go to the another design, another stimulation? Can I get a yes from the chat box? Or else you need some more time. Yeah, okay then. Then we'll go to the Pir sensor now. Yeah. Yeah, anyone have any idea about the Pir sensor? Like what is it used for? Pir sensor. Any idea? Okay. The Pir sensor helps in detection of motion. When a person or an animal moves in and out of a sensor range, it helps in detection of motion. Basically, it detects the infrared radiation coming from the human body into the surrounding areas as our body releases heat energy in the form of radiation. And the sensor is what you'll find in the most modern security systems, like and also automatic switches and the garage door openers, like automatic door openers, and all the similar applications where we want to react to a motion. Basically, the Pir sensor helps in detection of motion. Everyone understood, right? Yeah. It contains 3 pins actually. One is signal pin and power pin and the ground pin. This signal pin, and this is also another thing. The Pir sensor is an analog sensor because based on the strength of the signal, it gives the signal between 0 to 1023 values when you connect it to the analog pin in the Arduino. We will connect to the analog pin because it is analog sensor, and we'll connect the power pin to 5-volt power supply, and the ground pin is as usually to the ground of the Arduino. Yeah, this is the connection, but it is very pretty much simple. Yeah, clear with the connections, right? If you are clear with the connections, you can go to the coding part. So this will declare. Okay, shall I move to the coding part? Guys, is anyone there? Yeah. Yeah. We'll declare two variables initially. 0, int a and b equal to 0. And in setup, there are only signal pin. We'll directly get the signal from the analog pin. So we no need to declare any pins here. Just for a serial monitor, we'll write the serial.begin function. .begin with the standard baud rate. As everyone know this. And in the void loop, equal to analog read. Analog read function helps in reading the analog value. As we connected the signal pin to the analog value A0 pin to the Arduino, this analog read helps in getting the value of analog value. And then we'll use the map function here. Basically, the map function, what is the use of map function provided by the Arduino language is, it allows you to map the range of values to a different range. Because, for example, here the analog values are ranging from 0 to 1024 values. If you want to change the 0 to 1024 values, you can scale up those values into whatever range you want. For example, if you take the condition like you are working with the Pir sensor and the servo motor, as the analog values of the Pir sensor is ranging from 0 to 1024, but the servo motor range is 0 to 180 only. So with the help of the map function, we can scale up the range of 0 to 1024 to 0 to 180. You understood? Basically, we are changing the range from one value to another value. So here I am changing the A value. Initially, the range is 0 to 1023. I am changing these 0 to 1023 values to 0 to 255. In my case, you can do whatever values you want. The value of B. E greater than 100. Detection of strong signal. Yeah. After mapping the values to 0 to 255, I'm printing the values of B. I'm checking the value. If the B is greater than 100, print like motion detected. Why B is greater than 100? Because it basically to check whether it is a strong sensing or not. Like for example, it might sometime wind also causes sensor to detect whether there is a motion or not. So that's why I'm checking if the sensor value is greater than 100, then it is a strong motion, and we'll find that there is a moving object in front of the sensor, and we'll printing the motion is detected. Let's try to stimulate whether there is no yeah, it's working fine. 0 0 0. See, I'm moving the object and it is printing that motion is detected because I'm moving the obstacle in front of the PIR sensor. If I stop moving the obstacle in front of the PIR sensor, it's simply printing the 0 values. Is it clear, guys?
What does the B value indicate? Is it a distance or?
No, it is also, it can range from 0 to 255 values, anything. It is not mandatory to put it is not mandatory to use the map value here. I'm just explaining you can change the range values. We can directly use the A here. Like if A is greater than 100, see. Now also it worked fine. See, the motion is detected. See, in the previous case, it's printed as 253. Now it is printing as 1018. Right? Why? Because in the previous case, I changed the range values to 0 to 255. So it is scaled up to 0 to 255 and it prints the only 253 values. But now we removed the map function, so it can take up to 1023. That's why in this case, it printing some 1000 plus values. Clear?
Yeah. Okay, fine.
Let me give you this Tinker link. Try to tinker that, guys. If it is working perfectly, then type the working in the chat box. Is it working? Oh, link is not working. Wait. I'll see. Now check. Now check this link. Is that link working?
No, it says it's forbidden to enter the site.
Oh, okay. Ivan. Okay. last try this link. Else I'll provide all these links in the documentation.
It's not working. Will you just try changing the visibility?
Okay, actually I changed the visibility to public only.
You kept it share link. It is in share link. No? Now
Yeah.
give public.
Yeah, tried.
Public you have tried.
Okay, we'll see after the session. We'll add all the working links to the documentation attached to it, and we'll share it in the Discord and the WhatsApp. And also, if you see, we'll move on. Yeah. And also, there are so many sensors. Like these two are stimulation, and I'll show you other sensors also. This is the gas sensor. This helps in detection of toxic or explosive gases, and it is used for measure the gas concentration. And this is one type of sensor. And the other sensor is piezoelectric sensor. This is piezoelectric sensor, and it uses the piezoelectric effect to measure the change in pressure, acceleration, temperature, strain, and etc. With the help of this, we can measure the pressure and vibrations, etc. And there are so many sensors like flex sensor is available, photoresistor sensor is available, and also temperature sensor is also available here. This is the temperature sensor. With the help of this, we can find the temperature, etc. And some IR sensors also available. Actually, it is always good to stimulate virtually before going to the hardware. And the software provides so many components to work with. And also try exploring the other sensors and components available in the software. If you are getting any doubts, we are there in the Discord servers and the WhatsApp. You can message anyone at any time. Not only this software and also other softwares like fridging. I'll type it in the chat box. It is also a type of sensor. It is also a type of software, sorry. In this also you can find so many type of sensors. Try exploring that website also. Yeah. That is from my side, guys. If you are having any doubts, you can ask.
Maninda, please paste the other link also in chat box.
Which link, Ra?
The other one you suggested, right? They could not see. They only saw. Okay, yeah.
Yeah.
Okay. Send it as a link also.
Yeah. Okay.
Okay, guys. There is a small quiz link in your chat box. Please do attend the quiz. And the announcement we have for you guys is since today is day 4 and tomorrow is day 5, we are keeping track of participants who are active with our sessions, and we will be recognizing your efforts only if you are taking this as a challenge. 14 days of robotics as a challenge. So this is a week 1, and when we are entering the week 2, that is the phase 2 of this entire schedule, you will be having a project by the end. So there is much more exciting stuff for you soon. And tomorrow and day after tomorrow, like tomorrow is actuation and day after tomorrow is kinematics. After tomorrow's session, we will be removing the names of the participants, those whom we find to be inactive. So we cannot tell each and every detail how we are going to process this. But we recommend you to be active and attend all these sessions as much as possible. We will accept any genuine reason if you are having any, such as your end semester examinations or something. So please inform your friends, and you will receive an email also regarding this tonight. So the recognition for your challenge is what termed as certificate. All right. I hope that is clear. If you are having any doubts, just unmute and speak. Otherwise, you're good to go. Please fill the form. I mean the quiz. So based on your responses, either they are right or wrong, we are going to process the attendance. So yeah, any other doubts you guys have, you're feel free to ask either in chat or you can unmute. Yeah, this platform is open for doubts or Q&A. Is any doubts regarding the quiz or any of our processing details or any doubts regarding previous sessions? Anything, you are welcome. You can feel free to come and tell us. If you have any queries, you can reflect back on the same mail through which you are receiving the mails. We'll respond as soon as possible. Yeah, thank you everybody for attending the session hosted by me and Vanindra. Yeah, thank you Vanindra for being a support for me.
Thank you, Dheeraj.